Welcome to today's webinar. We're going to be talking about fighting financial fraud in real time with AI. I'm Seshadri. I'm the Chief Evangelist at Aerospike. And we're going to be talking through some lessons, we at Aerospike have learned about fighting financial fraud, working with some of our top customers like PayPal, Barclays, TransUnion, etc. So without further ado, let's get into the talk. So today we'll first outline what modern fraud defense entails, right? So what are the aspects that have changed over time and how are fraudsters kind of trying to commit fraud, if you will. Then we'll do a brief introduction of Aerospike as a database and then get into how Aerospike is a great fit as a data infrastructure for fraud detection. And then we'll talk about some of our customer innovation stories. So that's the plan. Okay, um, let's talk about how fraud defenses evolved from handcrafted rules to what I call real-time inference using machine learning and graph technology. Um, but before we go further, let's understand the landscape. So it's an arms race, really, right? With fraudsters, there is a fraud arms race going. The weapon is on both sides, the defense side as well as the offense side. The defense side being you folks trying to prevent fraudsters from committing fraud. There are weapons of speed and scale that are being used on both sides. And there are trillions at stake. I mean, various estimates, go from 1.5 trillion at the minimum to even 10 trillion, and so on and so forth. That's the cost of the fraud, the fraudsters committing fraud. The cost is direct sometimes, it's indirect in terms of reputation, and so on and so forth, right? Lost opportunities, so there are plenty of costs. And what happens typically is milliseconds decide millions of dollars. That means you got to detect fraud in a span of few milliseconds. And if you don't, you might let a fraud slip by, and that can have pretty bad consequences. So it's all about milliseconds, and we'll talk a little bit more later. And like I said, it's a war between the fraudsters and you. So the adversaries are evolving, and they're constantly bringing in AI, bots, automation to the play, if you will. And it's a cat and mouse battle, right? That you have to play. And of course, in all this, the challenge or the trade-off is you have to protect your customers, the security, but at the same time, you have to make their experience smooth and pleasant. So it's very easy to say every transaction is a fraud. Yes, you will never have a fraudulent transaction happen in your system, but you're not going to have a customer either. And flip side, you can let every transaction happen. All your customers who are committing genuine transactions are happy, and so are the fraudsters. So really, it's about what's called the false positive and false negative, and managing that and keeping both of them down to a minimum, right? So ensuring that all the correct transactions go through and all the fraud transactions do not go through. And finally, if you do this well, it's going to be a competitive advantage. Firms that master low latency fraud detection will lead their sectors. So it's smart, what shall I call it? Customer approval, customer loyalty, and so on and so forth. So that's the benefit of dealing with fraud correctly. Okay. And AI is in a critical path. Fraud today has to be handled using predictive AI, and it means that you have to make decisions in line. So you cannot afford to take decisions slowly, because that's not a good customer experience. But at the same time, you got to make decisions, fraud decisions very quickly, because it has to be in line. So every credit card transaction has to go through a fraud detection in a matter of milliseconds. People want to open bank accounts in a matter of minutes, and so you got to do background verification in a matter of minutes, and so on and so forth. So everything is in line, and you've got milliseconds to act, like I said. So and even if you let one transaction, even if you don't have predictable latency for one of the fraud transactions and let it through, that can have disastrous consequences. And therefore, tail latency matters. It's not about getting your average down. You got to have predictable latency. You got to have your 99.9 percentile up there in terms of whatever your SLAs are, right? And all of this is happening at massive scale, millions of reads and writes. And so this is a classic problem, as classic a problem, and as good a problem for AI as possible. Okay, so let's talk about the fraud prevention maturity that we have, right? So there are olden days, long back, there were probably static. What shall we call it? Identification. These are fraudsters. These are not fraudsters. That's about it. Then we evolved into something called rule-based systems. I will show you a few rules shortly, but they were fairly rigid. They couldn't change. They did not have cross correlation across attributes and so on and so forth. And then ML inference was born, which is able to do such cross inferences as we will see. But even ML inferences happen to be at a transaction level. They look at a single transaction and everything surrounding it and make decisions. But really what's happening is fraud is becoming all about relationships. People, as we will see, launder money through chain of accounts. Then there is a bunch of people that, the same fraudster shares multiple devices, creates multiple accounts. So really, you need a graph view or a holistic view, of the relationships that are going on. And you can first, as a first step, import this graph view as features into your machine learning model. But many times you actually have to update this graph and consult this graph in real time. That's the peak, if you will. So you got to do machine learning plus real-time graph inference. So here's some examples of rule-based risk assessment. I'm not going to sort of read out everything here. The point is you can create rules. It's like what I'll call trying to fill up holes in a dam with your fingers, right? So it's you're going to keep holes are going to get up everywhere, and soon you'll be using your toes too. So the point is you cannot. I mean, this is a very old technique, and you really can't scale this. There are endless lists. Then there are, what I'll call magic constants that appear in your rules that are very population dependent, not specific to you. Velocity for you may be very different from velocity for somebody across the globe, so on and so forth, right? So anyway, long story short, fragile system, not really something that scales in modern era. So pretty much, most people have evolved to what's called ML inference. So you evolve from rules to ML inference. And I think the primary thing that you get with ML is you're constantly retraining on new fraud patterns. And you're ingesting hundreds of features simultaneously and understanding their non-obvious relationships between those features, unlike rules where each feature was treated independently. And not only that, you're not saying, simple rules like if this is less than 50 or if somebody has done something 3 times, blah, 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 but you're learning what are called optimal decision boundaries, which could be fairly convex combinations, if you will, of all these attributes. And that's what helps you with ML discover hidden complex fraud patterns. Okay, so ML is sort of how people are dealing with fraud. And here are some sample features that machine learning could use for fraud detection. There could be user behavior features. There could be device and network features. Historical and aggregated features and graph-derived features. So there can be any number of features that you might bring to bear using an ML algorithm, and that's what you sort of end up using. I already mentioned briefly why you need a notion of a graph, right? So because fraud is all about connections and relationships. There are rings, there are mules, sometimes unwitting mules, sometimes conniving mules, and so on and so forth. But doesn't matter. As a result, it takes a network to find to fight a network, as they say. So there's a network of rings, mules, collusion, and so on and so forth going on. And while any one transaction may look like it's okay in isolation, in reality, what people try to do is to achieve fraud through a sequence of transactions. And you will not understand something is a fraud unless you understand, the sequence, if you will, or the global picture, if you will. So you got to worry about what are the connected components, what are the communities that are forming, and so on and so forth. In any case, so the output of such graph computation, if you will, becomes features that you can use in a machine learning algorithm. Going even beyond what I call offline graph features is using the graph in an online manner or in a real-time manner. So, offline graph features kind of, obviously you do training once a day, maybe a few times a day if you're extremely agile, but that's about it, right? So, but fraud and, the graph changes in the order of seconds or minutes. And, there is a sequence of chain of transactions that gets sort of completed in the order of seconds or minutes, and you got to detect that chain in real time, so if you will. And so the offline features lag, and fraud rings can cash in and cash out in minutes, and so you need what's called real-time graph inference. You need to figure out what's going on with multi-hop laundering. So there are, you're doing k-hop traversals, and then there's a time decay to make sure the more recent edges are given the weight that it's required in a real-time graph, and so on and so forth. So again, this is not meant to be a complete talk on fraud, but I just wanted to give you a glimpse of the complexity of fraud detection. Okay, and then my goal is to now say how Aerospike helps in this journey for you. Okay, so let's get introduced to Aerospike. So let's talk about why, at a very high level, Aerospike is a great fit for fraud detection. And this is true not just for fraud detection. This is true for many predictive AI patterns, even some Gen AI and agentic AI patterns. But we'll focus on fraud for this webinar, right? Aerospike, the key advantage it provides over other databases is it's able to provide very high throughput at very low latency and ultra high reliability. And therefore, we power mission critical use cases and workloads across a multitude of Fortune 500 companies. It could be PayPal, could be TransUnion, could be many others. So that's one of the key characteristics. The second key characteristic is we do all of this at a very low total cost of ownership. Routinely, we go in and replace, other databases and bring down the server usage, if you will, by 70% or 80%. So, for example, here in LexisNexis, there was a 70% server reduction from Cassandra. So you dramatically reduce the server footprint. And finally, we get used in machine learning and AI routinely. For example, Barclays revamped their whole machine learning pipeline, fraud pipeline, which was a conglomeration of multiple databases, multiple parts stitched together, and they were struggling both with the quality of the output as well as with the performance of that. And then they replaced with Aerospike as a single database that could sort of solve all the problems. And yeah, they got a 80% lower latency, 4x throughput compared to Cassandra. Okay, so that's a sort of an overview of Aerospike. Now let's dig a little bit deeper into what Aerospike actually does. It uses something called hybrid memory architecture. Okay, so the essence of hybrid memory architecture is it leaves the data on disk but stores what's called a primary index in memory. And as a result, compared to other databases that keep, let's say, all their data in RAM, such as Redis many times, they are much lower cost. I mean, the performance at the same performance. So you can have your data in RAM, or you can have it on disk with the primary index in RAM. And because network is the bottleneck resource, we have optimized everything so that the end-to-end latency for the client to server looks like a millisecond or under a millisecond, just as it would for data in RAM. If you go the other direction, so many people keep the data on SSD and then do some kind of aggressive caching. Yes, that's one way to bring down your cost of infra, but then usually their performance drops dramatically. They are able to go maybe 5 millisecond, 10 millisecond kind of latency for a record read and a write, whereas here it's sub-millisecond for error spike. So in some ways, that's the secret, right? So that's how you get your high throughput, low latency at a low cost of infra. Sort of throwing a little bit more light, not only is it low latency, but it's at a very low variation. And you'll see that's a very important thing. This is called the tail latency. So if you see here, Aerospike is much lower latency than Cassandra, which is up here, but it has very little variation, right? So as a result, the tail latency of Aerospike is going to be very low, whereas the tail latency here is going to be somewhere up here, right? 8 millisecond. This is going to be sub-millisecond. Okay. And all this at the lowest cost of infra, like I said, routinely there is an 80% reduction in the server sizes. Whether it be Redis, whether it be Cassandra, whether it be Couchbase, routinely there's been an 80% reduction across many customers, Azure, TransUnion, Criteo, and so on and so forth. And all this we have to do while staying real time against threats anywhere in the globe, which means that we have to be able to take our database and replicate it anywhere in the globe in the matter of seconds and keep it somewhat consistent with what's going on at the core. So the trading is happening at the core. This is the source of truth, if you will. And using our patented XDR technology, we are able to sort of replicate this, if you will, or propagate this, if you will, to clusters that are very close to the edge, whether it's Australia, whether it's UK, and so on and so forth. Okay, so that's what gives people who are in that region the ability to contact their local databases and get their, sub 50 millisecond end-to-end fraud detection pipeline, if you will. Okay, so now let's sort of, that's whatever I described so far is a very generic description of Aerospike that applies to all, all use cases. Let's dig a little bit deeper into what is the data infra for fraud detection and why is Aerospike a good fit. And to understand that, we have to understand what is a typical fraud detection machine learning pipeline architecture. And this architecture is very similar to, many machine learning pipeline architectures. There is an offline batch, data that comes in, it's ingested, and features are extracted, and then you might store things in some offline storage, and then you might do some training, and then finally you'll load an online feature store. Okay, and there is a bunch of real-time sort of information that's coming in. You ingest it as a stream, and then the features are also getting loaded in an online fashion. And then whenever a transaction is initiated, you kind of go ask the ML inference or the fraud inference engine, is this okay? And then the fraud inference engine will come back with an accept or reject, but that is based on what's stored in the feature store, okay? And this feature store and state store, or even inference cache is definitely one of the main goals of Aerospike, if you will. And this is where Aerospike plays a role in the whole machine learning pipeline architecture. But before I get into that, let's even more motivate why you need an Aerospike here, right? And to do that, I'm going to double click on this ML inference a bit. So usually what happens is ML inference in production, this is a slide from PayPal, is not a very simple one model, one inference, right? There is usually some kind of model composition, sequencing, and selection going on, or you have different pieces of data going to different models, or you have an ensemble of models all operating on all the data, but then making independent decisions, and then you combine. So the bottom line here is models are complex, inference is complex. In particular, let me motivate what I call a 3-stage real-time fraud inference pipeline, right? So you kind of, and many ML inferences are multi-stage because for multiple reasons. In this case, the reason is that whatever decisions you can make quickly using simple models, you want to do it. So there might be some rules model that you can make some decisions very quickly. It's the same recurring whatever bill from PG&E that is getting paid, nothing has changed, the credit card remains the same, whatever, right? The addresses, and everything has been the same, has been going on for 2 years. There's not much sort of a discussion on this. And then, obviously there are many techniques you could use to do rules-based. I mean, although I say rules, you will still use some logistic regression or XGBoost and so on and so forth. This happens very quickly. A lot of cases get handled, say 70%. And then you might come to a sort of for the borderline cases, you may say, okay, let me sort of dig a bit deeper. Let me do a small DNN on this. May take about 5 milliseconds, And then finally, you do a deep contextual model or a deep neural network for the really hard cases. That might take 15, 20 milliseconds. So the point is, there are multiple models that are going to be deployed in production, which really means that you're going to dip into the feature store multiple times. So look at this picture. So in the top is what I call a basic feature store, where you dip into the feature store and then you do some, let's say the first model that I talked about, rules-based. Then dip into the feature store again and do the intermediate twist step, and then you probably run out of your budget. You only have 50 milliseconds. Whereas in the second, which is where you're using Aerospike as a feature store, Aerospike takes only a sub-millisecond. So let's say this was about, 10 milliseconds, and this is about 1 millisecond. So you're able to do this, and then you can do the first step. You're able to do again another feature store lookup, the second step, another feature store lookup, the third step. So basically, you have more modeling steps, right? Not only that, because you have taken less time for each of the feature store lookups, you have more time for modeling. And finally, and most importantly, actually, if you notice the y-axis here, that's the data volume. You can get a lot more data from Aerospike for the far smaller amount of time. So if you see this height of this is much more. So the area, the blue under the blue sort of squares or rectangles, if you will, is way more at the bottom than at the top. This is what we call give time back to the models. So don't hold it in the data layer, right? So the data infra should try to do things fast so that the models get the time. And that's where you're going to get your quality decisions from. And so this is the crux of why Aerospike is an awesome fit. And nobody can say it better than our own customers. They say Aerospike on a technology basis allows us to do more complex risk calculations in less time. A more thorough risk calculations allows better accuracy for our customers to avoid friction in the transactions, avoid losing money in fraud. So I think best captured by our customers here. Cool. I think that was a very quick intro to fraud. What I'm going to do now is to sort of talk about a few scenarios that our customers have gone through and sort of highlight them for you. So you hear it in our customers' own words, and these are slides from their presentations. I'm going to start with PayPal. And, this is sort of a quote from PayPal, right? PayPal is innovating deep analytics to rapidly respond to emerging fraud patterns, accelerate detection, reduce losses, and achieve near continuous availability. And what happened was, they wanted to identify fraud patterns in milliseconds, and that is the situation before. They want to, scale a fraud-proven solution with hundreds of terabytes of data, and they got it with us. So massive scalability and cost savings, 30x reduction in fraud exposure. This was the most important thing. What was happening was that SLAs, their 99.9 SLAs, were constantly exceeding the budget they had, which meant that they could not be sure about some transactions. They had to approve it for customer delight, right? And so their fraud exposure was much more, whereas with Aerospike, they could dramatically reduce that fraud exposure while supporting a higher throughput, having lower number of servers. I'm going to do one more customer real quick here, TransUnion, okay? So what TransUnion does is it sort of works with other banks. I mean, these are slides from them. It works with other banks to sort of, especially for account opening, to validate or invalidate whether all the information is correct and whether there's any identity fraud going on and so on and so forth. And in the initial version, what was happening was the bank was kind of reaching out across their network to the TransUnion network, and that was, several times very slow. Okay, so there were internal and external networks, and the calling TransUnion across VPNs and so on and so forth was becoming a bottleneck. And really, if you will, one of the learnings that they had was real-time identity verification requires current context of the transaction, along with historical information, of course. So they wanted to keep the data close to the application. In other words, even though their customers were different entities, legal entities, they wanted to somehow keep the TransUnion data close to the customer, in the customer's network, and we'll come to that and how Aerospike helps with that, right? And then, of course, they want everything in predictable millisecond. We already talked about it. So I'm going to sort of talk about what TransUnion did, right? So they used what's called Aerospike, cross data center replication, and were able to use their data center as the core and all their customers as the edge. You remember we talked about how you can move the data to the edge. And obviously, they could do it because Aerospike it does not re-architecting the application. It was the same Aerospike database, which was communicating in their customers' network as well as their network, and it was smooth. Yeah, of course, you need to worry about security and so on and so forth, because now your data, TransUnion's data, is in the customer's network, and again, Aerospike was able to sort of handle all of those issues for them, and of course at the scale and speed that they wanted. So essentially, TransUnion sort of benefited from these features of Aerospike, if you will. Okay. And finally, I'm just going to quickly talk about Barclays, and then we'll conclude and take questions. So Barclays, what they were able to do is they were able to dramatically reduce what's called standard processing, which means basically they could not make a decision in the time that they had. So they kind of sent it for standard processing. Of course, data consistency issues, reducing false positives and false negatives, and so on and so forth. Again, great story. It was built for growth from day one. They reduced the TCO by having a single system, not having a complex labyrinth of systems that were working, and it was a great story. Yeah, I will take questions shortly, but just want to leave you with some helpful links. If you want to try Aerospike, you can try now. You can take this QR code. If you would like more info or talk to somebody from Aerospike, again, you can get in touch with us. And finally, I want to sort of alert you to a hands-on workshop that Aerospike is running. It's all about real-time fraud detection with graph databases. And Art Anderson, head of developer relations, is going to be running it. And it's going to be on Wednesday, September 3rd. Again, this QR code will help you learn more about it. Okay. That's it for me now. I'm ready to take questions. Thank you, folks.